Hybridization. Here I am going to show you the trick how to find the hybridization quickly. For that we have one condition, that is we have to add lone pair electron and bond pair electron. And if the sum of this lone pair and bond pair electron comes 2, then the hybridization will be sp. If it comes 3, then it is sp2. If it comes 4, then it is sp3. And if it comes 5, then it will be sp3d. If it comes 6, then it is sp3d2. And if it is 7, then it is sp3d3. Not only the hybridization but also the exact geometry of any molecule we can calculate, we can determine by using this trick. Now some of the example associated with it, and for that the first I have selected this ammonia molecule. These are certain compounds in which the central atom we have to specify for finding the hybridization. The first example which I have written here, that is ammonia. Here these are the bond pair electrons. So we have 3 bond pair electron and 1 lone pair of electron. If I add these two, then it is 4, and answer is sp3 hybridized. For H2O we have 2 lone pair and 2 bond pairs. So again 2 plus 2, that is 4, and it is sp3 hybridized. For methane we have 4 plus 0, that is sp3 hybridized. For PCl5 we have 5 plus 0, so it is sp3d hybridized. For SF6 we have 6 bond pair and we don't have any lone pair, so total number of orbitals which we have, that is 6, and the hybridization is found to be sp3d. If I of 7 is taken, then we have 7 bond pair and we don't have any lone pair of electron, so the hybridization is found to be sp3d3. Even so, now I am going to explain these conditions where the sp3 hybridization is, but each of the hybrid orbital have the different geometry. See, if 3 bond pair and 1 lone pair electron is present, then with sp3 hybridization the geometry will be pyramidal. If 2 bond pair and 2 lone pair of electron is present, then the geometry will be bend, and if all are bond pair, then the geometry will be tetrahedral. We have one more condition. We can have one last example associated with this topic, that is IF. Here we have 1 bond pair and 3 lone pair. Again it is sp3 hybridized, but its geometry is found to be linear. So this was the trick by which we can calculate, we can find the hybridization of any of the molecule, as well as we can predict the geometry associated with the number of lone pair of electron and the bond pair of electron which is present. Thank you.
The exact